In this chapter, I want to show you how to apply cloth physics to your assets. First of all, let's have a look at how physics and collision work in general in Unreal Engine. So, basically any object you place in a level is nothing more than a visual representation of something. It has no physical properties per se. For example, let's place our helmet in the level, and let's set collision to no collision. If I jump into play mode, you see that the helmet is not doing anything. It's not falling down, it is not interacting with the world, and I can just run through it. So the fact that it is a piece of geometry does not really give it any physical properties. The way that it receives its physical relevance in the Unreal world is via a collision capsule. You can visualize the collision objects if you go to Show and enable Show Collision. Since we disabled collision on the helmet, there is nothing here. So let's enable collision back again and set it to default. Now you see the collision object that is assigned to the helmet. Unreal automatically generates a collision object for any mesh that you import, by the way, so you don't need to worry about that. Now let's scroll up a bit and enable Simulate Physics on the helmet. If I now go to Simulate, the helmet actually falls down and interacts with the floor. If I were to disable collision on the floor, the helmet would just fall through it. So the takeaway is, any physical interaction in the Unreal world happens through those collision objects. It's those capsules and boxes that interact with each other, not the actual meshes themselves. Depending on how well the collision object wraps around the actual mesh, your physics simulation will look more realistic. Why are we talking about static meshes? Well, it is important to understand that there are two major types of meshes in Unreal. We have static meshes, which we just looked at, and skeletal meshes. The difference between the two is much deeper than the fact that the skeletal mesh has a rig and can be animated. When it comes to physics and collisions, skeletal meshes work in a very different way. One important thing to know is, if you want to apply cloth physics to a mesh, it needs to be a skeletal mesh. Even if it is a simple flag, it needs a rig for cloth simulation. Luckily, our cape is already a skeletal mesh since we rigged it to the MetaHuman skeleton. So, how are physical properties applied to skeletal meshes? For example, our hero character doesn't show any collision object, although we activated Show Collision. For skeletal meshes, Unreal needs a physics asset. For example, let's have a look at the UE5 mannequin. In the Details panel under Physics, there is a physics asset assigned to this character. Let's open it up. And here is where Unreal stores collision information. Because a skeletal mesh is capable of changing its shape, like move the arms, legs, etc., a simple collision object wouldn't do. Instead, we can assign collision capsules to specific bones. Usually, you don't need a capsule for every bone in the body, just a few suffice for most use cases where the character needs to physically interact with the world. The same applies, of course, to our MetaHuman body. It also has a physics asset. Now, you may have noticed that when we imported the clothes items, Unreal automatically generated a physics asset for each item. But if you open it up, you will see that it is not very precise. The nice thing is, we can assign any physics asset to any skeletal mesh as long as it shares the same bone hierarchy. Since I want the cape to interact with the body of my hero character, it makes sense to just take the body physics asset and use it for the cape. That is what I'll do next. Duplicate the body physics asset, rename it, and then go to the physics asset slot of the cape and assign the new one. That means that the cape now uses these new collision capsules for physics simulation instead of the one that was automatically generated by Unreal. I can now also delete a couple of bones, which are irrelevant to the cape anyway. So these capsules are now the ones that our cape cloth sim will collide with. And here lies one of the complications with cloth simulation on a character. Depending on how you position those capsules, the cape might look unnaturally far away from the body or clip through it. This will require some iterations and fine-tuning, but we'll get there once we apply the cloth physics. This is our next step. Let's go to the cape asset and then to the clothing tab. First, we have to tell Unreal that we want to apply clothing simulation to this mesh. You can just select it here in the viewport, then right-click on it and select Generate Clothing Data from Selection. You can change the name of the clothing asset if you like, make sure that cloth simulation uses our new physics asset, and click Create. This newly created asset will now appear in the Clothing tab. This is the asset where all your vertex weights and cloth physics parameters are stored. You can create several of these if necessary, by the way. Next, before we do any weight painting, we need to assign this clothes asset to the skeletal mesh. Right-click on the cape and select Apply Clothing Data. So, now let's select the clothing asset and click on Activate Cloth Paint. Under Cloth Painting, you have 4 tools that you can use: Brush, Gradient, Smooth and Fill. For the brush, the main parameter is the paint value. The number here means the number of centimeters that your cloth vertices are allowed to move from their original position. So a value of 100 means that the vertices you paint this value on will move 1 meter from its original position. This is something to play with. For some parts of your garments you might want to set this value to something smaller if you only want minimal movement. I leave the value on 100 and paint the lower part of the cape. Using the brush tool will usually result in extremely sharp transitions between vertices that are not moving at all and neighboring vertices that move a lot. So we can now change the tool to Smooth and then click a couple of times on Smooth Mesh, which will introduce a gradient between the 2 vertex values. Now let's click on Deactivate Cloth Paint and see what we got. You can assign a preview animation directly here in the asset editor to see how the cloth behaves. From here on out, it's an iterative process of playing around with cloth parameters, repainting problematic areas of the cloth, and changing the size and position of the collision capsules in the physics asset. There are 2 things to know for a better simulation result. First, in the physics asset, you are not limited to the capsules that are there. If you click on the gear wheel icon and select Show All Bones, you will see the whole skeleton tree. Now you can select any bone, right-click, go to Add Shape and add a capsule or a tapered capsule. You can also create several capsules for 1 bone. Second, to access the cloth simulation parameters, go to Config and Cloth Configs. There are 2 groups of parameters. The second group has an important simulation parameter called iteration count. This is what used to be called solver frequency in UE4. Lower values will result in stretchier and bouncier cloth, and setting this value to say 10 or higher will make your cloth more heavy if you want. Especially if you have leather, jeans or similar fabrics you want to simulate, you might want to crank this up a bit. The other parameter group, called Chaos Cloth Config, has different properties you can play with. An interesting one is the collision thickness, which is the distance in centimeters your cloth will stay away from the collision capsules. Especially if you have lots of clipping issues, setting this to 2 or 3 might solve it easily. Under environmental properties, you can change the gravity to make your cloth look even heavier or change some of the other coefficients. All this is very specific to your garment shape, expected behavior and material properties you would like to simulate. Just let the simulation run in the editor while changing the parameters to see which effect it has on your cloth item. Yeah, and that's basically all I wanted to show you for cloth simulation. There is so much more you can do with cloth simulation, but this would go far beyond the scope of this course. Feel free to read up on the documentation and experiment on your own. As a last topic, let's quickly look at groom physics as well. I created this shoulder pad fur asset for my character, for example, and would like to apply hair physics to the particles. If you open up any groom asset in Unreal Engine, you will see a tab called Physics. The only thing you need to do is to check the Enable Simulation checkbox on the top of the Physics panel, and you're done. It's as easy as that. Alright, this concludes the whole clothes creation pipeline for characters in Unreal Engine. In the next chapter I will also introduce you to the Alembic cloth animation workflow, where you basically simulate the clothes behavior directly in Marvelous Designer and then export the animation data as a geometry cache file to be used in Unreal. See you there!